In this notebook, we're going to explore the factual question, can functions in Python modify arguments? And the philosophical argument question, should functions modify arguments? So for the first question, the answer is functions can modify some kinds of arguments. Specifically, mutable arguments, such as lists and dictionaries, can be modified within a function, whereas immutable arguments, such as strings, integers, floats, and tuples, cannot be modified within a function. So as to the second question, the answer is generally we don't want to modify arguments, but sometimes we have to. So it's generally considered bad style to modify an argument in a function. It makes it hard to track what a program is doing. It can lead to inconsistent code. And in the paradigm of functional programming, which is a style that's in resurgence to try to make more efficient use of modern computer hardware, they try to eliminate all modifications of variables, and they refer to this, if you read the literature, this is referred to as side effects. And you don't want a program that has side effects in that milieu. In reality, as at least I've experienced it, sometimes you have to have functions that modify the arguments that come in. And if you do that, it's considered the best style that if you modify an argument, always have the function return a value of none. So it's not returning some new value, it's returning a none, and that function is, the only thing you get out of that function is a modification of the argument. You're not getting a modification of the arguments and some new value returned from it. So let's just look at two brief examples. The first, I defined a function, can I modify a string? And I've got my doc string here, and so what I'm going to do is I'm going to take a string and I'm going to reverse it, assign it to itself, so I'm trying to modify the string here, and I'm going to see what my value is when I as my input to the function, and then I'm going to look at what the value is after I've modified this function. And then, so that's within my function, can I modify a string? Outside of that, I'm going to define a string1 equal to this is a string. I'm going to call can I modify a string? And then I'm going to see if the value of string1 in this namespace of the cell, if whether that's changed. So let's look and see what happens. So my input within can I modify a string is this is a string. My modified string is nerts si. But when I come out of the function and I look at what my value of string1 is, I see that string1 has not been modified. So string1 remains what it was before I called can I modify a string. It was unmodified. Okay. Now let's look at the same thing with a list. In this case, I have a function, can I modify a list? It takes a list and it's going to modify that list by appending the string modified to it. And I'm going to do the same thing. I'm going to print what the state of the list is as it comes into the function. I'm going to append the list. I'm going to print out the value, verifying that I did do the append. So I'll see what the values are within the function. And then I'm going to look at what's the state of list 1 after I have called can I modify a list. You see here we have the list. This is a list with the number 1. I modify it within the function. This is a list with the number 1. Let me say I've modified. And now outside of the function, in the global namespace of the cell, list 1 has been modified. It has the modified in it. And that is in contrast to the behavior of string, which was not modified. So in summary, we can modify mutable objects. In programming parlance, what we're saying is mutable objects are passed by reference to the function. That is, the location in memory where the object is stored is passed to the function and it can be manipulated directly. Whereas when I'm passing an immutable object, such as a string, to a function, it is being passed as what we would call passed by value. And that is, a copy of the object is passed to the function, and only the copy is accessed and manipulated by the function. So we have passed by reference for mutable objects, which allows them to be changed by the function. And we have passed by value for immutable objects, which means that they cannot be changed by the function. So you might ask why the difference, and it's probably a trade-off in performance. That if I'm going to pass a list in and not have it be modifiable, I have to copy it. And copying a modifiable object is much more expensive than copying an immutable object. And so it's just a trade-off in the design of the language between kind of the safety of not having something, not allowing something to be modified in a function, and the performance of how much cost it takes to save you from that possibility.